What is a singularity? The place where physics itself gives up. Somewhere in the universe, there's a place where the laws of physics just quit. Not bend, not stretch. They flat out surrender. You could take every equation humanity has ever written, every theory Einstein perfected over a decade of sleepless nights, every number physicists have checked and rechecked for over a century. And at this one spot, all of it turns to gibberish. The math spits out infinity. The clocks stop meaning anything. Space and time themselves come to an end. And here's the part that should genuinely unsettle you. This isn't science fiction. It isn't a wild theory from some fringe corner of physics. It's the direct, mathematically unavoidable prediction of Einstein's general relativity, the most precisely tested theory we've ever produced. It's called a singularity. There's one at the heart of every black hole. There was one at the start of time. And after 8 minutes with me, you'll understand why some of the sharpest minds on Earth are still losing sleep over what's really hiding in there. So let's start with the basic question. What actually is a singularity? In the simplest terms, a singularity is a point where gravity has crushed matter so completely that it occupies zero volume, but contains all of its original mass. Think about that for a second. Take the sun. Take something 15 times the mass of the sun. Take an entire dying star. Now, squeeze all of that down into something smaller than a single atom, smaller than a proton, smaller than anything. A point, mathematically speaking, with no size at all. What you get is a density that isn't just huge, it's literally infinite. The gravity isn't just strong, it becomes endless. And the curvature of spacetime, that four-dimensional fabric that holds the universe together, becomes so extreme that spacetime itself tears open. But here's the twist most science videos skip over. Physicists don't actually believe true singularities exist. When infinity shows up in your equations, that's usually not nature being weird. That's your theory waving a white flag, telling you it has reached the edge of what it can describe. A singularity is less a thing in the universe and more a signpost that reads, "You've hit the limit of human knowledge. Turn back." To understand where this idea came from, we have to rewind to 1916. World War I is raging. A German physicist named Karl Schwarzschild is serving on the Russian front, calculating artillery trajectories by day, and, incredibly, solving Einstein's brand new general relativity equations by candlelight at night. Just weeks after Einstein published his theory, Schwarzschild found the first exact solution. And buried inside that solution was something bizarre. If you packed enough mass into a small enough space, his equations predicted a boundary, a radius beyond which nothing could escape, not even light, and at the center, a point where the math simply broke. Schwarzschild himself died of a rare autoimmune disease just months later, at age 42. He thought his strange result was a mathematical curiosity with no connection to reality. Einstein agreed. For decades, most physicists assumed singularities were artifacts of the math, a glitch, not a genuine prediction about the cosmos. Then came Roger Penrose. In 1965, a young British mathematician named Roger Penrose published a paper less than 3 pages long that would reshape physics forever. Using a clever new mathematical tool he called a trapped surface, Penrose proved something nobody had managed before. If matter collapses past a certain point, and in general relativity, nothing can stop it once that line is crossed, the formation of a singularity isn't just possible. It's mathematically inevitable, no matter how messy the collapse, no matter if the star is spinning, no matter what kind of matter you throw in. You end up with a singularity every single time. 55 years later, in 2020, the Nobel Committee finally gave Penrose half the Nobel Prize in Physics for that work, with the citation reading, and I'm paraphrasing here, that he proved black hole formation is a robust prediction of general relativity. The other half went to Reinhard Genzel and Andrea Ghez for tracking stars whipping around the monstrous black hole at the center of our Milky Way. So when you hear about a black hole singularity, understand, this isn't speculation anymore. A Nobel Prize was awarded specifically because mathematics forces reality's hand. Now here's where it gets even stranger. Black holes aren't the only place singularities show up. Rewind the expansion of the universe. Keep rewinding. About 13.8 billion years ago, everything you see, every galaxy, every star, every atom in your body was compressed into a region vanishingly small. And if you follow Einstein's equations all the way back to time zero, you hit another singularity. The Big Bang itself. Infinite density, infinite temperature, the very beginning of space and time. Penrose, along with Stephen Hawking, later extended the singularity theorem to show the universe itself almost certainly began this way. So, what would it actually feel like to fall toward one of these things? Well, if you picked a small black hole, a few times the mass of our sun, it would be unpleasant. Long before you reached the event horizon, the difference in gravitational pull between your feet and your head would become so severe that you'd be stretched into a thin stream of particles. Physicists call this spaghettification, a term Stephen Hawking popularized. And yes, that's the actual technical word. Your body would become a long noodle of disintegrating atoms spiraling toward the center. But choose a supermassive black hole, something millions or billions of times the mass of the sun, and the experience changes completely. The tidal forces at the event horizon would be surprisingly gentle. You could cross the boundary of no return without feeling a thing. No flash, no warning, just a one-way trip into a region where the future points only inward. Every path, every direction, every possible choice, all of them lead to the singularity. At that point, it's no longer a place in space. It becomes a moment in your future, as inescapable as tomorrow morning. So do singularities really exist? Honestly, probably not in the way general relativity describes them. Most physicists suspect that, when you get down to the smallest scales, quantum mechanics takes over and smooths out the infinities. Theories like loop quantum gravity and string theory are both hunting for a way to replace the singularity with something finite, something that behaves. Loop quantum gravity, for instance, predicts that inside a black hole, matter doesn't crush down to a point, but may funnel into another region of spacetime entirely. It's a clue that a deeper theory is out there, waiting. Until we find it, the singularity remains one of the last great frontiers in physics. A place where Einstein's masterpiece breaks, where time ends, where knowledge itself hits a wall we haven't figured out how to climb over. And somewhere in our galaxy, at this exact moment, there are billions of them, waiting, silent, perfect. If this rewires how you think about what's out there, hit that subscribe button and stick around. The universe has much more to tell you.